Okay. Should we start? No? Let me check one more time. Hello everyone, my name is Shako, and I live in Berlin right now. I'm a senior software engineer at NordVPN, and today we are gonna talk about the architecture, Flask, how to combine all of them and to build some maintainable and testable software. So a few words about me. I'm leading also Azerbaijan Python user community. You can see our beautiful armor here, and pretty much the meaning is to have a peaceful coding. I did a bit of the PyCon conferences this year, PyCon D, PyCon Portugal, PyCon Lithuania. Two of them has no recording, but obviously Deutschland PyCon has a nice recording, so we can go and check it later. Also, there's a local community called PyBerlin here, and I'm actively sharing my knowledge. What we are going to build today. If you go to the Flask documentation, we can see that there's a tutorial section and with a pretty straightforward blog application. But the thing is that we are going completely to change it and to make it more robust and testable and maintainable. So this is a core idea behind this workshop. And I'm going to show one more thing before going on. So we are going to put the GitHub repository for this project as well, but when we start, I would like to deviate some time to share about the tooling, because it's important enough to understand what kind of tools we have under the hood and to improve our development experience. The first thing that I'm extensively using is the make files. So for me, constructing all available commands of the application inside the makefile is a neat way to structure your application. So whenever somebody, newcomer, during your onboarding process and other stuff, somebody reads it, it understands, okay, we have install, which is a production installation, which we have an install dev, which is a development installation. We have a pre-commit, enabling pre-commit hooks. So it gives a hint to you that, okay, we have a decent pre-commit hooks to use the make build command, then make format and make lint. What's important about using command style in the project or in the team is whenever the new persons join to your team, it's really hard to manage the common coding style. That's why you force it, like how to say you add a CI checks, you add a pre-commit hooks before any kind of commit or before any kind of pull request. It's going to be formatted and linted. This is a important thing to have a common standards in the project, in the team. Of course, we have a type check command, which is a static like type hints checker, I'd say. We use PyType, and there's also alternative. There's a MyPy, you can go with that. Secure checking, of course, in every application, you need to have an extra eye on a security. And there is a standard checks on the security which you can add to your tooling. For example, pip audit, safety check, or bandit. So these three are free and you can use them during your development. Regarding the tests, so the test, I really would like to stress the importance to differentiate between tests. So we have tests, we have test flow, test integration, and with PyTest marks, you can differentiate between your tests. Then you have a test coverage, then you have initdb, which is a Flask command to initialize a database. Then you have a run command, which is going to run your application. So when you type a make run, for example, make initdb, then a make run. So obviously this is a development server, and it's going to give you the IP. Then we can go with our application. So Flask post. So this is a pretty much about this application. You register, you log in, then you create a post, then you can edit and delete the post. We are going to test it extensively. No worries about that. Now let's start with the folder structure. So the folder structure I follow is the top root folder is source, and then inside it you have a blog, and then different kind of the folders that you have any standard on it, or you can invent on your own. I'm going to show you like prototype or subtype or hexagonal architecture here, and that's why I just have here adapters, then ports, and then a configurator, which is a top level configurator, which you put your configs or settings or dependency injection containers. We're going to see what's it. And of course, we use PyProject TOML. This is a modern way, and we use Fleet for package package management. So it's not for dependency management. Dependency management can be managed by Poetry, but Fleet is neat and like decent. It has been in the market, I'd say, for a long time, and you can check it. The importance using PyProject TOML is differentiate between your development dependencies, test dependencies, and the production dependencies. For our application, we are going to use a dependency injector, which is a dependency injection library, and a Flask, obviously, and a Pydantic for our validation. Yes, we are going to use Pydantic with a Flask. And the next thing, so what's the reason of the application? What's the understanding about the application? The application is, so project layout is, it's a blog application, as you see. But here, so I can show you from the documentation. But obviously, the official tutorial, I don't know, for me, it's like lacking a modernization. And that's why I decided to build a pretty much complete new view to the old tutorial. So first question, let's start with the domain modeling. What we mean by domain modeling is something that you ask a question. So the first question comes to the mind that when you build an application, you ask a question. And first question is, what is the user to us? And the user, then you got an answer. The user is a something that had UID, a username, and a password. Then the pretty much is in a data class, and these things is for equality check, a string representation, if this type is hashable or not. So those kind of, these are details, but most important thing to get an answer to your question. So what is the user? And the answer came, okay, the user is something with these three fields. But obviously, the main reason between this, let me give an analogy. Imagine that you are working in a bank, and bank has a loan team, and then bank has a customer care team. I don't know, front office and another. So for each team, the definition of the user can be completely different. There's a reason that you ask a question. Okay, so for the loan team, what is the user for you? And then for example, for CTO, what is the user for you? And then you combine all this knowledge and depict your knowledge in terms of the code. So this is, in a nutshell, what is the domain modeling. But obviously, there's kind of, okay, you have a domain model, the user, it's pretty much straightforward. And then you have a user factory, because I don't want to burden my validation logic inside the class, the domain model class, because domain model itself doesn't care about how it's going to be validated. It's like autoscope. And that's the reason that I built the user factory, and you put all kind of complex validation logic inside the user factory. And if all validation is succeeded, and then you return your domain model. Pretty much clear. But how to test this? So we have a user, we need to immediately test our code, and we have this test domain. So what I follow the structure of giving a same subfolders for the test as my main folder. So by going to the test domain, I understand that we have a domain tests here. So this is important on the naming to be a consistent as well. The next question, what has a post, right? And we are asked the next question, what is a post for us? And the post for us is something with UID, author ID, the title, body, created type. And again, equality check, the string representation and the hashing of this class. And one more time, the post factory, you put all kind of validation in the post factory, and then you return your post domain model. One more time, stressing, this is a domain modeling. This is it's nothing common with the database modeling. We depict our business logic here. What's the answer to our question? And then obviously, if we go to the domain, test domain models, let's see this test structure for us. So the test name also should be clear, and also it can help you understanding the code itself. For example, from my point of view, when I join to the new team or to the new project, one of the first things, I'm reading the tests. If the test is quite understandable, like it has a less cognitive load, that means the structure of the application is fair enough, like good enough. Let's go with the naming. So test create post valid parameters. So I would like to create a post with valid parameters. You can add like test create with valid parameters even. Then I create the post directly without the factory. And then I'm going to do the same thing, but this time with the post factory. So test valid input parameters. I'm passing the post factory. Then test empty string title. I'm checking if there's a string title, if the post title can be empty or not, and I expect here a value error. So different kind of scenarios you can build here. The one strategy also is constructing user tests. You can add a tags and to explain a bit more what the test is doing. For example, let me go up. So we have a happy pass. We can have an unhappy pass, but also we can have an edge case, which we have defined in our test. For us, it's the edge case because we find some kind of, for example, post 1, post 2, and we are checking if they not equal or not. So this is pretty much not day-to-day everything to check. We understand this is an edge case for us. So then we put a tag like general behavior. I don't know, most of the things is edge case, happy pass, unhappy pass, a different kind of stuff. So this is a comprehensive test for just checking our domain models. But we are not done with the domain models. I need one more thing before hitting a domain model. So it's kind of, if you see the dependency pass, it's going outside to invert. So something is going to use our domain model from the outside. And this is crucial thing. Before hitting the domain model, we should cover it with a defense layer, more defense layer, because this is a most crucial part of the application. It's the heart of complexity. Pretty much. Then we go with the schemas. What's a schema? So how we are going to use our user? Obviously, user must be registered, and then it must be, I'd say, it must be login, it must be validated before that, and then you define your DTOs. DTO is data transfer object, and I define it as a pedantic base model. So here it's quite, I would say, straightforward. the register user input DTO is mimicking our domain model here, but it can choose to mimic or not mimic. The idea behind it, it can be the exact the same thing, but it can be also a total different thing. And one more thing. So when I register user, I have an input. So it's something that comes to create a domain model. But also I need to return back some response. Then I define the output or reply response DTO. And here I eliminate the password. The reason for differentiating an input and output is to eliminate the accidental information disclosure. So if you return just back a user, you cannot catch on an upper layer. For example, service layer just directly returns back your user domain model. Even entry points like web layer returns back, somebody can disclose your sensitive information, for example. That's why you are different. Obviously here is a simple example, but for more complex scenarios, it can be more important to differentiate between. And here we have a register user factory, one more factory. You can initialize UID in a factory or see below for pedantic usage. So the thing is that, for example, you register user input DTO. For accessing this, you are calling register user factory, and you can add here all kind of initialization for your pedantic models. The same goes with the post. So we have UID. So this one is a manual UID for creation, but this one is using the pedantic field and with a default factory. They are pretty much the same thing, but the machinery is different. And that's why I put this little comment here. So after ID, obviously it has a UID for type and the title and the body and the created. And here, as we have a bit more complex logic, we are going to have a pedantic validators here. So validator for the body, validator for the title, the validator for the title and body combined, and other stuff. So all kind of validation is out of scope of domain modeling. So here, for example, I can put the all kind of validation here, but when the validation logic changes, I need to go back and touch my critical sections. But that's not a best practice. Your critical section should just work fine, and it must not has any kind of third-party dependencies. This is a rule, the general rule. And here we have a create post factory. One more thing that update post. This is important. As you see, we have different kind of post values when we create it, but at a low level, we allow only updating title and a body. And obviously UID is for understanding which post we are going to update. It has update post factory, and for the deleting post from our database, from the application, you see we support only deletion by UID. So we say that we agree on that nobody should be delete their post by title or by body, and we got an answer and we depict it in our code. So all the code should have an intention. It's kind of self-explanatory thing. And then you have a delete post factory, and obviously each layer. So you have a model, right? You have a port, you have services, repositories. Each layer can have its validator and can have a schemas on that. And I put usually the validators inside the model. And by that, I understand that this validator is for model. So this is how it works. And I have only one, I'd say, external validator, which I'm checking here that if the UID path is indeed a valid or not. Checking the chat. Okay, all good. Now a bit more a different architecture style that we changed here. So we finished the domain modeling part, but now it's kind of we need to separate different responsibilities in our application. And as we said in the beginning of the live, we are going to use the hexagonal architecture, and one name of this is ports and adapters. That's why we have a port and then an adapters. Okay, we have a domain model. Then we need to have one more abstraction on that, and we can go with services here. So what is a ports and adapters? In a nutshell, ports and abstraction, an adapter is a concrete code, concrete implementation. But it's not such easy, but I'm just a way more 100 times, I don't know, 1,000 times simplified version of that. Let's see what we have. For the services, we define an interface. An interface, obviously, we have no such facility in a Python to have a decent like Java-like or Golang-like interface, but we have abstract-based classes, and that's why we mimic the interface and we call it interface. So what the interface, you define what you support. So we support creation of the user, right? It accepts the register user input detail and it returns back register user output detail. And it's called internal protected create user. So this is my own style I follow, but you can also call directly the business logic inside, the creation logic inside it. But I use it in, and you will see how it's, for me, it's way more cleaner. Then to get user by username, and it returns back, it accepts a username string, and then it returns back an optional user. But obviously, why optional? Because if the user not found, you are going to return back a none here. We support getting user by UID. So all public methods there is our clear contract. So we agree whenever somebody is going to implement our interface, they are going to have 3 public and also 3 protected methods, which is abstract methods. Why we define the abstract method, not why, but the rising not implemented error here is also guarantee that if somebody tries to implement it, he or she, obviously all, must implement all. So there's no such thing like selective implementation. And this is kind of a guarding, like extra safety net, defensive layer of our user service interface. So if interface is defined, that means in the adapter side, there should be a concrete implementation of this user interface. So user service inherits or implements the user service interface, and it has let's say it has a dependency of unit of work. We are going to see what is unit of work and the layers. As you see, there's kind of different layer, repositories and the unit of works. But in a nutshell, there should be like user factory, and it opens a transaction to the database, it adds the user, and then commits it to the database. Then we support get by username and get by user by UID. So we have 3 protected methods which we can use, which we must implement in our implementation. And then, yeah, services user and unit of work user. So this user factory is from the model. So this is our user domain model factory. Clear? How about the tests? Let's just go with, oh, I'm missing the service test. No, probably not, but yeah. Okay, we talked about the unit of work, and now, as you see, there's we talked about user service, and it has a dependence of unit of work interface, which is pretty much an abstraction over a transactional capabilities of your database. And for that reason, let's talk about some more about the databases. So in the original blog post, where it is, in original blog post, we have this define and access a database, and it has a def get db clause and then creating tables, and obviously it has a different kind of direct calls. I need to find it to the database. So it calls the database comment inside the view, which is a bit violation of single responsibility, because my view is not gonna be responsible to the database itself, the operation of the database. It's just responsible for accepting the request and returning back a response. And that's why on top of the database, we need to have some kind of abstraction, and we call it repository. So it's called the repository pattern for the user. So we define a user repository interface, and for the user repository, we support adding, getting by UID, getting by username, and getting old user. And of course, then executing the command to the database, and then my abstract method. So by that time, it should be clear what's the design, what's the style of the application. You have a public methods in a contract, then you have a protected method as an abstract method. Then you define your contract interface, then you go to the adapter and implement the concrete version of your interface. So user repository accept a session. So this is a database session you open, and then it defines what kind of exact implementation you have. So execute calls the session execute. It's a layer repository pattern in a nutshell. It's an abstraction layer over your database action. So here in blog post, the Flask documentation uses direct SQL commands, and I just preserved it. But obviously, if even you have a ORM, you can have a repository abstraction on top of your ORM. So this is also the important aspect of that. Here you define add. How are you adding to the database? You expect a model user. This is a domain model, and you insert it as an execute, and you catch the exception. So each import side, each layer can define its custom exception. So I have a blog DB operation error. I have a user DB operation error. And from the user side, so it's pretty straightforward. Inserting and selecting star. Again, I just copy it from the official documentation. So you can argue that star is evil, but yeah, I did it as it is. Then get by UID and then get all. So checking UID, checking user name, and then fetching all, fetching one. So pretty common database operations. The same true with the post. For the post, we have interface one more time. What kind of functionalities we support? We support by get by UID, get all, update by UID, delete, execute. And then you need to go to the adapter side. You need to go for the post, and for the post repository, you have this concrete implementation of the post. So it has a bit more functionality because we support updating the post, we support deleting the post, but we do not support updating deleting the user, for example, and we just do not put anything there. For the execution, yeah, it executes a query to the database. Any questions? Nothing. The next thing to explain is related directly to the repository, but also it's related to how we manage our transaction in our application. The one pattern, it's called unit of works, and I'm going to show you how it operates in under the hood. So the user has a user, so unit of work interface has a user repository interface as a class field, I'd say, and it supports so basically those facility is supporting the with statement in the Python and like context managers. And when we enter like with unit of work interface, it opens, or we'll see in a concrete implementation how it works. But this is a context manager. Then we have a commit and a rollback functionality. So I put it rollback as it is. You see, I didn't call underscore rollback. This is a style that I'm going to just show here two different styles for the learning purposes. For the adapter side, the unit of work, obviously the unit of work in the port side, unit of work in the adapter side, and if you go with the user, so if you type with unit of work, it opens a session. You see, it enters the context manager, it opens a session, it creates a user repository, which was defined as a field here, you see, and then it returns back. When it's exit, it just exits. You can choose to close a session as well, but I just commented it here. What is commit doing? It's calling the session commit, and rollback is calling the session rollback. The session is a database, exact database session, which in our current application is SQLite. The same scenario with the posts. For the post unit of work, they're pretty much the same things, the exact exact action. Okay, we can have a question here. If we have 50 database tables, does it mean that we are going to have a 50 repositories there? Well, repositories or unit of work. You can always generalize the things. You can accept your dependency here as a dynamic value and initialize your tables or repositories, I would say, in one centralized manner. Or what you can do, you can have some registry that, okay, I have a 50 tables, please register it. It's pretty much as an Orium. So if you have a 50 tables in Orium, you are going to define your 50 models, right? That is the same logic. So it's not like okay, it can feel like over engineering, but believe me, it really deserves more attention because it gives you a powerful functionality or facility to test your application. Enough about the unit of work and repositories. I'm going to devote some more time to the test now. How we can test the repositories. For the repository, this is important. We can fake it. So there's a common two strategy. Either you build a test database and fill all kind of test data in it and use your real code to test it, or you can fake your classes. How? For example, get fake user repository. If we go to the conf test, so in the conf test, this is a PyTest fixture. In the conf test, we can have this get return back fake user repository, and where we defined fake user repository in the fake repositories here, and a fake repository, again, it's it conforms with the contract which we define. So it's a true interface. So it implements our interface. But here we don't want to have any database outside connection. We fake it with the dictionaries. So we still have add, get by UID, get all, execute. Obviously, we don't need the execute here because there's no database to execute. Update by UID and deleting the thing. But we all operate on a dictionary level. So this is important that it gives you a powerful mechanism. When you have an interface, you can fake it and you can inject it to your application with the fake repositories, with the fake classes, and your application works like as usual. And here we just operate. So what does it mean to create for example, to add a post? It just randomly generated ID, and we put the ID the key as a key to the database dictionary, and the post as a value. The model post as a value. Again, this is a domain model, not a database model. This is how we fake it, and then the same thing with the fake, how we can fake a unit of work, or how we can make a transactions. So basically, the simplest idea is just to check if something committed or not. So self-committed false is always when we enter to the context manager, we create a fake user repository from fake repositories like here. So everything is faked. Fake user unit of work and fake repository. And then we have, whenever we call the commit, we check it like, okay, self-committed is true. So it's like we fake commit action. The same true with the fake post unit of work. So this is how it faked. Like committed false, then when something committed is committed true. But here we can have a pause on the idea. Okay, we have any kind of different layers, any kind of like abstractions. But the main question we can have is how you wire everything together. One common approach to this to use a dependency injection or dependency injection containers. And for the Python, we are going to use, as we talked, this dependency injector, the library, which is powerful mechanism. It is not one of the lightweights, but it has extensive features that I really like to use and to check. So in the configurator, we can go for the containers. Let's just define some more moment on how we are going to declare our how wire our application together. So that inside the container, we declare that this is a declarative container, and wiring config is something that we want that all these dependencies must be available to our blueprints, to our Flask application. So you see where we are going. So we have a domain model in the center. We have repositories, unit of work, services which use the unit of work, and on top of that, the external layer is a Flask. So Flask view has nothing common, or it has no knowledge about the business rules. The Flask is just an entry point, and that's why it's called an entry point. You see, in adaptive side, an entry point. Imagine this is kind of like you have a Flask entry points, and you have a CLI entry points, and you have a different kind of other entry points like REST API endpoint, or just a different framework from your list, like favorite list. And it's pluggable. So if your architecture is good enough, it's pluggable. So this is the common idea behind. So you got a maintainable, more testable application. Inside the container, we initialize the database connection. Then we initialize a post unit of work and pass this to the session factory. So this is callable. So it's a singleton. The post service uses post UAV, and post service is a factory, is also callable. The user unit of work requires a database connection, but it is itself a dependency to the user service. This is kind of chaining your dependencies, and then finally, you just put your service into the Flask blueprints. We are going to deviate a lot of time on the Flask. Obviously, this talk about the Flask, but I would like also stress one more time here that the most important thing is to understand what problem is your application solving. This is a blog application, and everything should be around the blog. I can have, or I must have an ability to build, for example, CLI for my blog application. If I burden all kind of logic, like business logic, inside the web layer, I cannot extract it. Either I cannot test it easily. So this is the problems of the common applications. And one thing that we can go with a test, so we call the I just confused myself. So we define the fake repositories, fake UAVs, and then how to wire up the total thing. We can define our fake container. So this is where you can differentiate between your test database and the production database. For example, here I have a test DB and I use this as my fake container. So this is my production container. This is my fake container. I fake the database connection, but the rest is from my production work. This is also the thing to understand. So you can either fake your container and use your classes as it is, or as I show, you can fake the repositories or fake any layer because it's pluggable, it's independent. You can easily change or fake any part. Now, okay, the fake container is clear, right? When I fire up the test, it's gonna to open or create a test database, and all kind of actions is going to run against the test database. So we don't pollute our production database. We are good on that. Let's go with the test repositories, and let's see. So test add user. Here I get a fake user repository, and I get a get user model. The user model is a fixture of the PyTest one more time, and I call user factory. So I register user factory. This will return back a Pydantic schema, and then I'm extracting. So this is an extra layer of the defense. Then I extract the UID, a username and a password, and call the user factory, which is a domain model factory, and return it back. I mimic how my Flask endpoint will use it. It should call the Pydantic schema, then it should extract the fields and create a user factory domain model. Then it's going to save the domain model to the database. So this is a pass. Your tests should not act an independent facility. The test is a bare bone of your application. It can simulate your flow, total flow, and this is the thing. One more thing that's powerful about the tests. Get post model. We again create a post factory. Get fake container for this. This is the fixtures we define, and we init a DB and fake container. Then so we are going to have this Flask. Not yet. I'm going to back to the tests. Test get user by ID, test get user by username, get all users, and we all use fake user repository. We have no database, but we were able to test our application. That is the power of the abstraction as well. It's the same with posts. We have a fake post. We have the same thing like get post model, which is fixture, and it's create a post factory. One more time is a post schema, the database schema, and then we pass all kind of stuff to the domain factory and get back the domain model. How about the unit work? Testing the unit work, it's again, one more time, is easy. So we have a get fake post UAV, and it is a context manager. When we enter to the context manager, we already have a repository. And let me show you what I mean here one more time, because it can be confused. So if we go unit of work, and we are talking about the post, right? And when we enter, we have already a database, and then we have a repository. This post, the repository post, where it was. Not a post here. Sorry. So this, I just confused myself. web host. No, we are talking about UAV. Sorry. So this pod here is a repository from the repository pattern. So it's kind of post when you enter the unit of work, it opens a connection to the database. It initializes the post repository and assign it to the self post. That's why I can access it through the UAV context manager. It has a post and add. So one single transaction. If anything bad happens, you roll back inside that. So this with block is a transaction. You operate in a transaction. And it's clear. Open a connection, add it, get it back, operate something, commit. In my test, I didn't use, I guess, a commit because I don't need, but we will see that in an integration test, it will be clear that, in fact, we need it when we use a true unit of work. So far, so good. We completed the domain, repository, the unit of work, and the services. But how about the Flask? Now it's time to talk about the Flask. The Flask acts an entry point to our application. And this is the basic thing. So I just grabbed whole thing one more time from official Flask documentation. If we go to the application, so here it's a bit different because now we are using what? Now we are using a dependency injection container. And in order to activate the container, we need to call it. So this is pretty straightforward. We register the blueprints, we init the app, we add URL rule. One more time, this is all from our application, from our documentation. So if you go, if we go back, application setup, yeah, I just get all kind of stuff from here, but obviously I don't want, I don't know, make some instance pass. I don't want to use this thing. I don't want to mapping from the config here. And as you see, the secret key is div, and I am going to, in the final stage of our talk, we are going to hack our application. So it's live hacking session. It was a surprise, but I'm just giving a little spoiler for you. Just wait until the end. And we will go and hack our application with this, with a lot of things, but yeah, let's continue. So we activate a container, we give a secret key as a Patrick, not Dev, but still weak, right? And then we share our container. So in application context, shared context, we save our dependency injection container and return back the application. So this is, if you have a Flask experience, this is pretty straightforward, the most things that people doing. Then we have a blueprint. So static and the templates, one more time, it's just, I grabbed all this from the blog documentation. Regarding the blueprints, let's go with the OWSPy. This thing is from the blog post. One more time, all imports, all functionality, I didn't change anything. But here we see a bit different approach. What is it? So for example, we need to check if the user we need to load the logged in user. Loading the logged in user requires getting the user by UID, but getting the user by UID is a responsibility of the user service. And here we just automatically inject it from the dependency injection. If you go here, we import it as a user service, but the actual object or instance of the user service is provided by a container. So this is a powerful mechanism. We just inverted our dependencies. When we start a Flask application, we don't need to create a user service instances because it's already here, like user service. You see the container and the user service. And here, we call it by the dictionary call, by the key call. And the user service name corresponds to the user service object. When the application starts, the user service is already available for our Flask endpoint. This is really a neat feature of the dependency injection. And it has an like cool decorator inject, blueprint inject, and voila, we have this user service get user by UID. Look at how it's clean. But if we go to the official, one more time, the documentation, and if we go to blueprint views, there is a register. I don't need it. See, so loading a logged in user requires a getting DB directly from opening the connection inside one logged user and directly putting the select statement here. So this is, and how to test it. It's nearly impossible to test it. I need the database and anything, but here we just can have a fake user service, and that's it. So we can easily test it. Also, we separate the concerns because loading a logged in user, in fact, doesn't care how you retrieve the user. You define how to retrieve the user, and this is a bit, trade-offs. You do a lot of stuff before hitting your entry point, but how clean the code. So this is much more important. And if somebody on your onboarding process, or if you are new in a team, or you introduce your application to some point, this is clean. It's easy to understand. You call a user service. Oh, it has a get user by UID. Let's just put a UID there. And this is the idea behind all these architectures, behind this all architectures. And let's talk about the registering the user. One more time, it accepts the user service. And then I'm checking if the post, I have a check username, a password. So this is from the official blog post as well, for official documentation. But the different thing is here, I call a register user factory DTO or the schema, and it returns back the pedantic output DTO. So if you go to here, you see register user, it returns back the register user input DTO, and then you send this schema, pedantic schema, to the user service create, and the create is not this one, but it was. And the create itself is responsible to extracting out all kind of information from the pedantic schema, saving it to the database, committing it, and returning back the data. Versus, so if you think about all business logic or all critical section behind the creating user is handled out of the Flask view. And this must be like this because the Flask view itself doesn't care how you create a user. It just waits for some kind of user data, and you return after successful register, you just redirect to the login. So success register, return back. We can check versus our code to the Flask code from the blog post, and here we just directly operates on the database level inside the view. Why it must be changed. Imagine that you change your database. Imagine you change your tables. Imagine you change your structure of your application. And each change to the database requires going back and changing your view. And it's going to be a more important if you are building an APIs, because whenever you are in a production with your API, It's a public contract. You cannot, I don't know, it once in a week change your API contract or behavior of your API endpoint. It should be decent. And that's why I don't know how to feel, how to explain the feelings. There are no direct database calls inside the view. The view just purely must be responsible only to redirect. Request, operate on request, redirect to response. No business logic inside it. The same for the login. So for the login, I require user service one more time when I validate username and password, because I need to check user by the username, and if there's not user, and obviously incorrect username, and it'll check password hash, and the password is incorrect. So this is how you check the validate username and a password. But one more time, in the future, you change your password hashing mechanism, or you change how you operate on the user, right? You don't need to go back to change the functionality of the login. The only change you require is in the service. You go and change the logic how you retrieve the user. This is important. So get user by username, and then, for example, imagine you need to change from the username, getting user by email, and if all this logic burdened inside the views, you are changing in a 50th place. But now, under the get by username, you just go and change the internal functionality of it, and now it returns. You didn't even break a contract. It returns an email, for example. It returns the user by the email. For the login, we are done with the login, and it obviously using a session and a cookie, and it stores the user in the session cookie as the user ID with the user UID. That logout is clearing the cookie, so nothing fancy, and redirect into the index. Again, this code portion is grabbed from the official documentation. How about the blog? The same procedure. For the index, when you load the application, I need all blogs, and I just inject the post service and getting all blogs from the post service, and rendering the template of the post index and passing the posts to this template. How it's powerful? So imagine the first thing that get all blogs returns 100, but in the next you have 100,000 of the blogs, and you don't want to return all. You just want a simple top 10, right? And you just go to the get all blogs, change your behavior, and your Flask stays untouched. Your endpoint stays free of change, I'd say. And here, for the creating a post, one more time, I need a post service, but I need also login required. And then I just validate the title and the title body error title, validate title body. And I'm not sure why error. Because of the sorry, it was in a documentation. So it accepts an error, it checks for the errors if there are any. And basically we check here that if title and body are missing, so just simple checks. And a post, like we create a post factory one more time, we extract the user UID from the session, and we pass the title and body. We create a post in the database, and we redirect to the main page post index page. Pretty much decent, right? So all business logic about creating a post, validation before hitting the service, all kind of stuff are just injected directly to our view. So we don't care about how the post created, how it's validated, how I don't know, after ID is truly UID or not, title length, body, nothing. All things is just operated by this create post factory. So you deviate or delegate the responsibility out of the scope of the Flask views. The login required, it's also an interesting. So UID, the post service, and you get post by UID. That obviously, if it's a post, no, it's update. Sorry. So this is an updating the post. When you update a post, it has a post service, gets a post, and then validate one more time because you can update it and inject something. I don't know, vulnerable, I would say, exploit something. And then update post factory, and I'm going to call the post service. And one thing about the updating, we support only the title and body updating. Yeah, I remember. Now I remember. Post input TTO. Yeah. But with creating, we support more. Yeah, this is how you differentiate between not ours, but I need blog. Deleting, we have no soft deletes here. We just remove it directly from the database because this is what's done, well, what was done in the official documentation. And between there's a difference here, nothing. So you one more time you get the post. You check that if you have post or not, and then you try to delete your post. Something went wrong with the database operation and block DB operation, and you understand that this is related to the blog. So exceptions also must be a self-explanatory. So it's kind of give an intention to you. What failed? So where failed? You see the exception, but what was failed? The failed things is a blog application, blog DB operation. So it's something wrong with the exact database operation, not with the service operation, not with the repository, or not with the unit of work, but exactly with the DB operation. And yeah, this is pretty much our blueprint. We can one more time look at how the blog, for example, updated in original documentation. So we get post, we check thing, and one more time direct database operations. No validation, no check, no even sanity checks that something is in a good shape. This is how I changed really the application and to try to sorry, I got a question. Any chance the font size can be increased? Yeah, sure. Where the font size? I guess in PyCharm. Yeah. So yeah. Tell me if it's good enough now. So yeah, this is basically the Flask section of us. But before hitting this, as you see, the most important things happened in domain layer, repositories, unit works, and services layer. One more question. Okay, we had a bunch of tests. We see how unit of work tested. We use a fake, but how we can really test with our Flask? We can differentiate the integration tests. Let's just go with the real unit of work. This is PyTest mark integration, so it's quite powerful mechanism. How you can do it? Go to the PyProject toml and you define your custom marks. For example, I have a slow and an integration, and also there's a deselect with. Like if you want not slow tests, you mark it as not slow. If you want integration or don't want, you put -m not integration. And in the make files, if you go to the test, for example, right? Ordinary unit tests, which we use a fake things, can be called not slow and not integration. So here you can have I don't know, if you have AWS test, right? You can make it as PyTest mark AWS and you call not AWS. And then it's just going to exclude your slow integration test. If you want only slow or if you want only test integration, you just part M, not no, not. And if we go to the test user UAV, we still get back a get fake container because if you remember, we need a fake database connection. You see, the fake database connection, but the rest of the thing is true. It's true database, but it's fake connection. Not fake connection, but it's a different database. It's a test database. It's not a production database. That's the reason that we still need the fake container. We open, we get the UAV from the fake container. And one more time, if you recall, the UAV is a factory, so it's callable. Singleton also a factory, so callable. So you need to call it to get back the unit of work, the actual object, the instance of this class. That's why we call it. We get it. We open a connection to the hexagonal test DB. We commit it. We check it, and we see that okay, yeah, the asserts that we create only one user, and it has the len of the one, and the username was me. And one more time, the test get user by UID. You get your UAV object. You open a database connection. You get the all users, and you check that okay, I was able to get back the user with the UID. Then getting by username, then getting all. So this is true tests, and we can indeed just quickly check what we have. So make test. It's going to run all the unit tests with the fakes, right? What we have. And here we can a summary that 52 passed and 11 deselected. Probably the deselected tests are integration tests. So again, you can make test. You can't see me. One more time. Yeah, make test integration. Then it's going to select this 11 and deselect the 52 rest, and we can check that our test database is also created here. Before that, so this is a production hexagonal DB, and this is a test database. So when we run integration test and call the fake container, it just created it for us. Yeah, the same true with the posts. So we call the fake container, we call get post model, we call the get user model, because we need to create a user first, and then we need to create a post. We call user UIV, we open a transaction, the connection, the commit create, then we open a post UAV to open the connection to the post database, post DB table or whatever you want to like say here, and then we add our posts. We check it, the title, all good. So first, because each post obviously should have a user, right? And in our test, we mimic it. Imagine like you register and you log in Flask app, then you try to create a post. So test is just following the same path. Regarding the testing, test get post by UID, fake container, getting post model. First we create it and then get back. Getting back all posts, updating the post by UID. First we get it back, the old post UID, and then we update it with the awesome title and new body. We commit it, then we check that old post UID is equal to the new post UID. So the test ensures that while you're updating, it's impossible to change UID. So there's the possibility of attack of changing the UID of the post. But here we prevented that it's only can update the title and the body. And then you check that UIDs still are equal, but titles change because the title is now, I don't know, more awesome. And testing delete by UID, there's the same thing. We get back the one of the posts, we delete commit, and we get all. Oh, okay, we have only one, and then get all should return back none, and we are done with the testing of the integration. So this is an actual database test run. How about the Flask? Good question. So we are testing the register user. We still get the fake container. We get a Flask client from the conf test. We can show you. Get Flask client. The get Flask app. So for the creating app, we update the testing true because this is a test environment. We yield app, and after finishing, we unwire or how to deallocate the dependency injection container. Then we get a Flask client back. So it's just returning the test client. This is something that built in the Flask. So we are pretty much done. The get Flask app is injected to get Flask client, and it returns back a test client. That means we can use it. So getting back a fake container, right, with the user service. And with the user UAV, we one more time get back the database connection and the repository, anything in unit of work pattern. But here, one more interesting thing. If you don't want to, have an actual, for example, user service functionality, you can always override your container objects with this command. So with container which we saved in the, you see, in the Flask app, with this container we saved, we want to override the user service with fake user service. And with fake user service, we get how you get it from the fake container. The reason we override it is to be one more time sure that the service operates on the test database, not on the production. Then we just post the register, follow the right redirects. We have some data. We check a lens. So it's a response history. We check that there was only one redirect. This is important to test also, because after successful register, we can have multiple redirects, and we don't want to have. We want to be sure that for our applications is only one successful. Then you must be redirected to the login. That's why we here check this lens. Then response request pass. We check that okay. We have like successfully redirect to the login. Then we get Flask client, and with Flask client we post one more time to the login. And again, if we have successful login, we should be redirected to the main page. We check this in our test. Then we open the user database. We check that indeed the user registered in our application, and then we one more this is also like important. We checking the user ID has this logged in user UID inside the cookie. How about the testing create blog post? This is the same thing. Getting fake container, getting Flask client, getting Flask app. We change the original production dependency containers user service plus post service. We override this with the fake ones, which we get from the fake container, to be sure one more time that it is going to operate only on the test database. And we get the post to the create. We create the post, we follow the redirects, we check a status code, and after the successful blog post creation, obviously it should redirect us to the main page, and then it is going to, I would say, yeah, we are going to check from the database, and then from checks that indeed we create the title test one. Wow, that was a long journey, and now we are done. We have nearly 100% of percentage coverage with just few steps. Each layer covered by step by step. So you have a domain layer, domain test, service layer, service test, and the Flask layer. You can have as much as fantasy here. So because I don't know, check all the validation. Obviously, there should be. This is a happy pass, right? You should have multiple fail pass, multiple edge cases for your Flask test as well. So this is important to understand also. But I just simplified it. So this is a power of architecturing of your application and testing it in a I would say isolation manner, then wire up everything together with a dependency injection container, and then test it in a whole chunk. All good. But one more thing that we need to understand. Let's just, okay, we have an application, but we need to check it thoroughly. So I'm going to, wait, this, play. I need my IP. This one is my IP. And I'm going to open up my Kali Linux. And then let's just check how our application acts. And I don't want it. It was cool. Zooming it a bit more. So register. Let's just register the user. That means so we act as an ordinary user. Then we go to the there's a boot suite. It's for pen testing web applications. It has a community edition, but I have a professional edition also. If you go proxy to HTTP history, now you can see oh, it's not, sorry. What's a get? No. I need to log out, log in, and let's just go to what happened to the proxy. Maybe proxy don't what. Okay, anyway, now it should work. Yeah, let me just check it. Check. Probably something wrong with my book. Sorry. Oh, I'm going to fire up. So everything can happen in the live stream. No worries there. We will manage it. Okay, crazy. Go there. One more time. I need to log in. Let's see if it works. Crazy. Something happened to my it's disabled. Re-enable. Why it's disabled? Sorry. So I need this one. Okay, that's, I need to traffic or proxy the browser traffic to the group suite. Yeah, no, it works. Okay, sorry. So Wiener, Peter, let's just explore what happened to our post. So we send a post request with a username and password as a body, and it turns back. I need to send it to the repeater for the clarity. Right, just log in one more time. And here, if I access my application, if you see, we have already a cookie session. It can be seen from the application as well. We have a cookie editor. You see the session, and the session cookie is like this. I don't know how called it, but usually the first part of the Flask session cookie, if you are using a built-in functionality, is base 64. And with the base 64, if you take a notice on the right side, it shows you the UID of the user, current logged in user. And this is, so the next is what is used for the building a session cookie. If you remember, we talked about the secret key. And if we go back with the secret key, project layout, that's one, application setup. So you see the secret key, how the Flask, there's session token, as cookie generated, it encrypts it with the secret key. And that means that if I know the secret key of the application somehow, I can decrypt it. This is crazy. There's like, never puts this dev here, and I can't see in a documentation that this is stressing out that, hey guys, please put it here, some encrypted random hash, don't use this plain text here. And this is how dangerous we will see it in a moment. But I want to emphasize that, okay, we are logged in as a winner, right? And the user ID of the winner is this. But also it's important thing to understand that in original blog post, the user IDs is just a sequential numbers, integers. But here I changed it to UID. It's a bit hard to predict the another user's UID. But if it was 1, 2, 3, that means I have an ID 1, and then the next user is a 2 or 3. It's really easy to enumerate the users. But here I just a bit, I'd say, hardens the time of the attacker. But still, somehow, using the different vulnerability in your application, if the attacker can obtain another user's ID, UID, right now, he has a still chance. And how? So this is VNet, yeah? I'm going to create a post. Cool. And let's just go back and create a post. So post, it still uses this section, and it understands that this post belongs to this user. And I can edit it because I am the owner of the user, this post. Then I log out. I'm going to register one more time with a different user, like Carlos, right? And then log in as a Carlos. Now I cannot, because I am not an owner of the post. The owner of the post is a winner. And if we go to the post login, we can see, just go send to repeater, and we can see that now we have a different UID. So it's now Carlos. But here it is the winner. All good. Now I would like to attack this application and steal a section of the winner. So I'm a Carlos. So this guy is Carlos. I'm getting this cookie session, then going here. And I say that Flask unsign, and I'm providing the session cookie. So this is Flask unsign is a reader application. You can check it in GitHub. But how it operates, I will explain it to you. There's the word list of rock.txt. There's a ton of million of clear text that is in this, and I am going to check if if the secret key of my application inside this word list. So let's just check it. It found the secret key of my application after 128 attempts. So it was a Patrick. And imagine if it was Dev, it will take like 2 attempts. So after getting the Patrick plus after getting the user ID of the Vina, we have the user ID of the Vina. You see, this is the Vina. I am going to create a new session cookie. One more time with Flask sign. Flask unsign. No. Wait, Flask unsign. And then we see sign. And the cookie is something that I steal somehow from XSS attack or any kind of different attacks that I steal from the Vina. And I know the secret. Then I can falsificate it's called session forgery. I can forge and create new session token for myself. I'm Carlos, right? And then I'm going to the cookie editor, put it here, save, and this is a magic. Now I'm a Vina. And I can edit. I don't know, imagine that I want to delete the Vina. So I have attacked the application. I get the secret key. I know the user ID. I generate a session token and I logged in to the application. This is how usually it happens. So don't put your secret key something naive. It can be easily forged and your application easily can be breached. This is pretty much the things that I would like to show you today, and I just showed you how it's important to have a secure, one more time, stressing on the security, stressing on layering, testability of your application, maintainability, and other things. Rather than, yeah, I have 2 hours, but 30 minutes we are done, like one hour and 30 minutes. So this is a whole story I would like to tell to you today, and I did it, hopefully. Now we can get the questions if you have any questions, and then yeah, we can say goodbye to each other. You can put your questions in a live stream chat if you haven't, or we can, I don't know, we can finish. Yeah, I can't see any questions. Probably everything's clear. You can reach me anytime you like. We have a question, sorry. So the question is like, what there scenario where you found a secret key in a production system that was insecure? Yeah, I know a lot of stuff that's going with the secrets. One thing is, for example, I see that a lot of secrets dumped to the GitHub repositories. I see that they accidentally put in an insecure way to the machine or exposed to the outside world. Plus, there can be the servers that runs the production plus runs the test environment, and then you mix accidentally again, you expose your secret and other stuff. So it's not quite rare, believe me. There's a bunch of dumps open, like resources in a GitHub, even in the internet, that you can obtain AWS credentials dumped to somewhere. I don't know, secret key credentials dumped to somewhere, and then you can like vcon on the attack surface. You can say you can broaden your surface. And plus, the idea behind what I was showing here is to understand that how simple steps can be broken. So you just overlook that it's secret key, but you need to understand where it's used. The secret key for example, it's used to create your encryption, right? And if it's naive enough, then it's going to be cracked. One more question: how would you recommend storing your secret key in a .env or env? So .env is not going to anyway. It should be in a git ignore, so no secrets in a repository, right? One thing you can do is to use an external secret service such as Vault, and then, for example, in your Kubernetes environment or in your integration at some point, you can read from the external secret, use it. Second thing that can be, you give the secrets during the build time of your application, and then you remove it. If there's all secrets requires for the build time, then you put it and then you remove it. Or you create .env inside your service dynamically while your application starts, getting from the environment variables. But environment variables should be somehow exported here. It is either from the secret store, it is either from, for example, Kubernetes secrets, it's either from like if you have any local secret store, or you can, like you have a facility when you start your application, you create .env dynamically, directly when your application starts, not beforehand, for example. This also can be a scenario, but usually the most big applications are using the external key storage like Azure Vault. I guess there is one, AWS secret store, or HashiCorp Key Vault. So this is the most common approach. One more question: would it be wise to keep changing it? Yeah, of course, the secret rotation can be a policy for you, like token expire, revoking tokens, changing the credentials, like changing role-based accesses. But all of these things can be not like once for the one single application. It must be for the full whole process, as a part of the whole process. When, for example, your key rotates once a week, right, automatically, you are pretty secure on that because it's just rolling update to whole applications, and you don't need manually change everything like single by single. This is quite powerful mechanism to use. Yeah, always keeps your secrets updated. It mostly must have some TTLs like expire section, and force users to use, I don't know if it's the internal thing, MFA. Update your MFA configurations. Usually keep an eye on it. Like don't share the secrets. One more thing here, that for example, the case that you should have inter team or inter project a company policy how you share the secrets between the employees. So don't send with the email, I don't know, don't send with the Slack. Usually there should be somehow shared secret store, where you put it, where you read it, and this store is also must have some kind of expire. And there are a lot of tools and companies constantly scanning all open GitHub repos for the credentials. Exactly. This is how they collect and sell this data. So it's pretty much crucial to keep eye on that. The projects which checks if secrets is dumped or not. So you can add this as a pre-commit hook. When accidentally you put it, it's going to prevent it. I can show you one more thing if we have time. So if we go make secure here, you see the bandit catches it and says that possible hard-coded password. So it's not going to allow you to commit this code. And by intention, I just omitted this security check run. But this is a powerful mechanism. It's free to use. You can add it as a part of CI. And then if somebody wants to push it to the application, hey, it catches and fails and merge blocked. And one more thing, that if you use a pre-commit hook, as I here, you can make it before commit. If somebody wants to commit this vulnerable portion, it's going to be prevented. This is also a powerful mechanism. So defense is not a one thing. It's like layered, multiple layers of defense. The web layer, then service layer, then domain layer, then obviously your infrastructure layer. And this is I'd say, a crucial topic. Yeah, we go to questions and answers. I like it. Yeah, if you have any, go ahead. Okay, no questions. We are gonna wrap up and say goodbye. Huh? Thank you for watching.